Hello friends, in this video we will again discuss about one problem involving multiple random variables. Okay, so let's assume that it is given that we have three random variables x1, x2 and x3, and they are again given to be independent and identically distributed, and the random variables will follow uniform distribution between 0 to 1. Now the question is, we have to evaluate the probability that the random variable x1 is largest. Okay, so before we solve this problem, let us first derive a general result and then apply that result to this specific problem. So for given random variables x1, x2 and x3, okay, so for given random variables x1, x2 and x3, so we have exhaustive set of events given by x1 greater than x2 is greater than x3. This is one event which is possible, and along with that we can have x1 greater than x3 greater than x2. Okay, and one more possibility would be x2, or I will write that in the next line. Okay, one more possibility would be x2 is greater than x1 greater than x3, and x2 is greater than x3 is greater than x1. And similar fashion for random variable x3 also we can have this combination, which is x3 greater than x1 greater than x2, and last combination would be x3 greater than x2 greater than x1. So we cannot have any other combination beyond this. So, and because all the random variables are independent and identically distributed, all these events would be equally likely, and hence each fellow will have the same probability of, so probability that x1 greater than x2 greater than x3 is same as probability that x1 greater than x3 greater than x2, and this is same as probability that x2 is greater than x1 greater than x3, and this is same as probability that x2 greater than x3 greater than x1, and again this is same as probability that x3 greater than x1 greater than x2, and this is same as probability that x3 greater than x2 greater than x1. And finally all these probabilities should be equal to 1 by 6, as all these events are mutually exclusive, and hence so probability that, or we say the event x1 is largest. Okay, so the event x1 is largest is same as x1 is greater than x2 is greater than x3, or x1 is greater than x3 is greater than x2. Okay, and because these two events are mutually exclusive, so probability that x1 is largest, okay, is same as probability that x1 greater than x2 greater than x3, okay, plus probability that x1 greater than x3 greater than x2. But just now we have proved that each of these probabilities is 1 by 6, and hence they should be the probability that x1 is largest would be equal to 1 by 6 plus 1 by 6, which would be equal to 1 by 3. Note that here we did not assume anything about the random variables x1, x2 and x3. So it is given that xi is uniform between 0 to 1 is just misleading, and hence here the random variables xi can be exponential or Gaussian or Laplacian or any other continuous random variables. Okay, and hence And because all these events are equally likely, we can say that probability that x2 is largest is also 1 by 3, and probability that x3 is largest is also 1 by 3. Okay, so if you are interested, you can extend this result to 4 random variables. Okay, so for example, we'll take that as homework. Okay, we have that if x1, x2 and x3 are 4 random, x3 and x4 are 4 random variables which are independent and identically distributed, then probability that x1 is largest would be equal to dash. Okay, and again we can extend the same result to n random variables. Okay, so extend, we can take that as also homework. So extend the above result to n random variables x1, x2 and so on up to xn. Okay, so hope this problem helps you in understanding evaluation of probabilities involving multiple random variables. Thank you.